All right, we're going to start with a couple more identities that we need to work on today, and we're going to talk about the sum and difference identities. And this is basically what's going to happen if we are trying to find the sine or the cosine or the tangent of two angles that are added together. So if I had the sine of angle A plus B. Now, your first reaction might be, well, isn't that just equal to the sine of A plus the sine of B? But I think I can prove to you pretty quickly that that's not going to be true. Okay, so let's take the sine of 30 degrees, which if you set up a reference triangle, you'll find is equal to 1/2. And we'll take the sine of 60 degrees, which is equal to the square root of 3 over 2. If I take the sine of 30 plus 60, which is the same as the sine of 90, that's equal to 1. 1 is not equal to 1/2 plus the square root of 3 over 2. Okay? I could do the same thing with cosine. The cosine of 30, so if I said cosine 30 equals, square root of 3 over 2. Cosine of 60 is equal to 1/2. Then the cosine of 30 plus 60, which is the cosine of 90, which is 0, is not the same thing as the square root of 3 over 2 plus 1/2. Same thing with tangent. Each one of these you should see that is just not what you would expect it to be. Now, there's a nice proof in your book for why the formulas are what we're going to use. I'm not going to go through that. There's actually other places on the web that you can watch that if you choose to see the proof, and I'd be happy to show you in class if you'd like to. But for now, I just would rather get to the formulas. These are something that you're going to have to remember. Okay? So I'm going to start with cosine. The cosine of A plus or minus B, this is why we call it sum or difference, is going to be the same thing as the cosine of A times the cosine of B. Now there's going to be a little difference there, and I'll explain. Sine A, sine B. Okay? So I did that so it would fit on the screen. So the cosine of A plus or minus B is equal to the cosine of A times the cosine of B minus plus the sine A sine B. So if I took our example and said the cosine of 60 plus 30, then according to this formula, it would be the cosine of 60 times the cosine of 30. Now, since this is a plus, the sign here is going to be the opposite of it, or the minus. And then I would say the sine of 60 times the sine of 30. And so this is going to be the same as the cosine of 90, which we know is equal to 0. The cosine of 60 is 1/2. The cosine of 30 is square root of 3 over 2. The sine of 60 is square root of 3 over 2. And the sine of 30 is equal to 1/2. And I think you can clearly see that 1/2 times the square root of 3 over 2 minus the square root of 3 over 2 times 1/2, those are going to be the same numbers, square root of 3 over 4 minus square root of 3 over 4, and that is going to equal 0. Okay? Suppose I wanted to do something like the cosine of 60 minus 30. Well, then I use the same formula, but now since I have a minus here, I'm going to choose the plus for that. And I would end up finding the cosine of 30 degrees, which I know is square root of 3 over 2. And when I do the math here, I'd get the square root of 3 over 4 plus the square root of 3 over 4, which is 2 root 3 over 4, which reduces to square root of 3 over 2. So this is something you need to know. That's the sum difference identity for cosine.